Welcome to the IIT Pearl problem solving session on arithmetic, geometric and harmonic progressions. We are going to have total 2 sessions on this. Today we start our session by recalling some facts about them. Let n be a sequence of numbers. We say this sequence an is in arithmetic progression in short we say AP if there exists A, D such that for all n bigger than or equal to 1 we have an is equal to a plus n minus 1 into d. This d is called the common difference of this arithmetic progression. We say this sequence an is in geometric progression in short GP if there exists A, R such that for all n bigger than or equal to 1 we have an is equal to a into r to the power n minus 1. We call this r to be the common ratio of this geometric progression. And we say this sequence an is in harmonic progression in short HP if there exists A, D such that for all n bigger than or equal to 1 we have 1 by an is equal to a plus n minus 1 into d, that is an is equal to 1 by a plus n minus 1 into d. So basically we say the sequence an is in harmonic progression if the sequence 1 by an is in arithmetic progression. Now we make a note here. If we are given 3 numbers A, B and C which are in an arithmetic progression, then often we write A as B minus D and C as B plus D, where D is the common difference of the arithmetic progression ABC. If A, B, C are in a geometric progression, then we write A as B by R and C as B into R, where R is the common ratio of the geometric progression A, B and C. If three numbers A, B and C are in more than one type of progressions, then we can derive the following about A, B and C. So our first case is three numbers A, B, C are in AP and as well as in GP. Since A, B and C are in an arithmetic progression, we write A as B minus D and C as B plus D, where D is the common difference of the arithmetic progression A, B and C. As they are also in GP, we write A as B by R and C as BR, where R is the common ratio of the geometric progression. From here we get AC is equal to B minus D into B plus D, that means B square minus D square, and from here we get AC is equal to B by R into BR, that is B square. So we get B square is equal to B square minus D square. So from here we can conclude that D square is equal to 0. That means D is equal to 0. Therefore, in this case we have A is equal to B is equal to C. So, if A, B, C are in AP and in GP, then they must be equal. Our next case is A, B, C are in both GP and HP. As A, B, C are in GP, we write like in the previous case, A is equal to B by R and C is equal to BR, where R is the common ratio, and as A, B, C are also in HP, we write A is equal to 1 by P minus D, B is equal to 1 by P, and C is equal to 1 by P plus D. Now from here we get AC is equal to B square, and from here we get AC is equal to 1 by P square minus D square. So equating this, we get B square P square minus B square D square is equal to 1. Note that from here we have BP is equal to 1. Therefore, b square p square is also equal to 1, and that implies b square d square is equal to 0. We have b is not equal to 0. Therefore, d has to be 0. Hence, in this case, a is equal to b is equal to c. So, we are getting if three numbers a, b, c are in both geometric progression and in harmonic progression, they must be equal. Our third case is a, b, c are in both AP and HP. As ABC are in AP, we write A is equal to B minus D1 and C is equal to B plus D1. Also, as they are in HP, we write A is equal to 1 by P minus D2, B is equal to 1 by P, and C is equal to 1 by P plus D2. We see that A is equal to B minus D1 as well as A is equal to 1 by P minus D2. Therefore, equating them, we get B minus D1 into P minus D2 is equal to 1. That is BP minus PD1 minus BD2 plus D1D2 is equal to 1. Now, from here we see that BP is equal to 1. Therefore, we get PD1 plus BD2 is equal to D1D2. Again, we have C is equal to B plus D1 and C is equal to 1 by P plus D2. We equate them. Equating them, we get B plus D1 into P plus D2 is equal to 1. That is BP plus PD1 plus BD2 plus D1D2 is equal to 1. As BP is equal to 1, we get PD1 plus BD2 is equal to minus D1 D2. Recall that here we obtained PD1 plus BD2 is equal to D1D2, and now we get PD1 plus BD2 is equal to minus D1D2. Therefore, we have D1D2 is equal to minus D1D2. That means D1D2 is equal to 0. That is D1 is equal to 0 or D2 is equal to 0. In either of the cases, we get A is equal to B is equal to C. Hence, we see that if three terms are in more than one type of progression, then they must be equal. This is our first question. we have three positive real numbers a, b and c, and the equation 9 into 25a square plus b square plus 25 into c square minus 3ac is equal to 15b into 3a plus c. We are given four options and we shall find out the correct answers. We start with the given equation. We have 225a square plus 9b square plus 25c square minus 75ac minus 45ab minus 15bc is equal to 0. Note that 225a square is equal to 15a whole square, 9b square is equal to 3b whole square, 25c square is equal to 5c whole square. We can write 75ac as 15a into 5c, 45ab as 15a into 3b, 15bc as 3b into 5c. So, this whole equation can be rewritten as 1 by 2 into 15a minus 3b whole square plus 3b minus 5c whole square plus 15a minus 5c whole square is equal to 0. We can see that all these three numbers are non-negative. We know that if the sum of three non-negative numbers is 0, then all of them are 0. So, we get 15a minus 3b is equal to 0, 3b minus 5c is equal to 0 and 15a minus 5c is equal to 0. That means we have b is equal to 5a, 3b is equal to 5c and c is equal to 3a. Now using these we can see that a plus b is equal to c by 3 plus 5c by 3. That means a plus b is equal to 2c. From here we can conclude that b, c, a, these three numbers are in arithmetic progression. So, the second option is correct. Now looking at the other options, we can conclude that none of them are correct. Now we look at our second question. We have 49 many numbers A1, A2 up to A49 which are in arithmetic progression such that sum over k runs from 0 to 12, A4k plus 1 is equal to 416 and also A9 plus A43 is equal to 66. Further, if A1 square plus A2 square plus A17 square is equal to 140m, then we shall find out the value of m. Note that the first term of the given arithmetic progression is A1 let D be the common difference of this given arithmetic progression. Then the rth term of this progression is of the form a1 plus r minus 1 into d. Now using this we rewrite this equation. We have a1 plus a5 plus a9 plus a13 up to a49 is equal to 416. Now we keep a1 as it is, then we write a5 as a1 plus 4d, a9 as a1 plus 8d, and so on and so forth. The last one is a1 plus 48d, and this whole thing is equal to 416. We have 13a1 plus 0 plus 4 plus 8 plus up to 48 into d is equal to 416. As there are 13 summands in this sum, so we get from here 13 a1, and from the first one we get contribution 0, and from the second one we get contribution 4, and from here we get contribution 8, and continuing like this, from the last one we get contribution 48. So therefore we have here 13 a1 plus 0 plus 4 plus 8 up to 48 into d is equal to 416. Now here there are 12 terms. We can rewrite it as, taking 4 out, 1 plus 2, and the next term was here 12, so this is 3 up to 12. So this is 4 into 12 into 13 divided by 2, which is equal to 13 into 24. So this equation turns out to be 13a1 plus 13 into 24d is equal to 416, and taking 13 out we get inside a1 plus 24d, and the whole thing is equal to 416. So finally we get a1 plus 24d is equal to 32. So this is one equation we have in a1 and d. Recall that we are also given a9 plus a43 is equal to 66. So therefore a1 plus 8d plus a1 plus 42d is equal to 66. That means 2a1 plus 50d is equal to 66. So we have another equation in a1 and d, which is a1 plus 25d is equal to 33. Now we can easily solve these two equations for a1 and d, and we get d is equal to 1 and a1 is equal to 33 minus 25 is equal to 8. Now coming back to the question, we shall find out the value of m, and we are given a1 square plus a2 square up to a17 square is equal to 140 m. I write it here again. We have sum over, let's say r runs from 1 to 17, ar square is equal to 140 m. Now we know what is ar. Ar is a1 plus r minus 1 into d, and we have already got the value of a1 is equal to 8 and the value of d is equal to 1. So therefore ar is equal to 7 plus r. Substituting it here, we get sum over r runs from 1 to 17, 7 plus r whole square is equal to 140 m. Now splitting this, we get 49 into sum over r runs from 1 to 17, here 1, plus 14 into sum over r is equal to 1 to 17 inside r, and the last one is sum over r runs from 1 to 17, r square is equal to 140 m. Therefore we have from this part 49 into 17, from this part we have 14 into 17 into 18 divided by 2. From this part we have 17 into 18 into 35 divided by 6. Solving this, we get m is equal to 4760 divided by 140, that is m is equal to 34. Therefore the value of m is 34, and so the first option is correct. This is our third question. We have three distinct numbers a, b and c. If logarithm of a plus c, logarithm of a minus c and logarithm of a minus 2b plus c are in arithmetic progression, then among these four given options we shall find out which are correct. Since log of a plus c, log of a minus c and log of a minus 2b plus c are in arithmetic progression, we can write log of a plus c plus log of a minus 2b plus c whole divided by 2 is equal to log of a minus c. That means log of a plus c into a minus 2b plus c is equal to log of a minus c whole square. Now exponentiating this equation, we get a plus c into a minus 2b plus c is equal to a minus c whole square. From here we get a square plus ca minus 2ab minus 2bc plus ac plus c square is equal to a square minus 2ac plus c square. So a square and a square here gets cancelled, c square and c square here gets cancelled. So finally we get 2 into AB plus BC is equal to 4AC, and this can be written as AB plus BC divided by 2 is equal to AC. So from here we can conclude that AB, AC and BC, they are in arithmetic progression. Therefore we see here that the second option is correct. Now we shall check the other options. Now among the remaining options, note that only one of them can be correct, as A, B, C are distinct numbers. Here we already got that AB, AC, BC are in arithmetic progression. So we can write that AB plus BC divided by 2 is equal to AC. That is, AB plus BC is equal to 2AC. So we have B is equal to 2AC divided by A plus C. We can write it as 1 by B is equal to 2 by 1 by C plus 1 by A. That is, 1 by A plus 1 by C is equal to 2 by B. So from here we can conclude that 1 by A, 1 by B and 1 by C are in arithmetic progression. That means A, B and C are in harmonic progression. So therefore the fourth option is also correct. This solves our third question. Here is our fourth question. Let A1, A2 up to A10 be in arithmetic progression and H1, H2 up to H10 be in harmonic progression. If A1 is equal to H1 is equal to 2 and A10 is equal to H10 is equal to 3, then we shall find out the value of A4 into H7. Let us first write what is A10. We know that A10 is equal to A1 plus 10 minus 1, so this is 9, into D, where D is the common difference of the arithmetic progression A1, A2 up to A10. Now we know what is A1. The value of A1 is given to be 2. So we have here 3 is equal to 2 plus 9D, because the value of A10 is also here given, which is 3. So we can conclude that D is equal to 1 by 9. So we have found out the common difference of the arithmetic progression A1, A2 up to A10. We have H1, H2 up to H10. They are in harmonic progression. That means 1 by H1, 1 by H2 up to 1 by H10, they are in arithmetic progression. Let us write what is 1 by H10. So this is 1 by H1 plus 9C, where C is the common difference of the arithmetic progression 1 by H1, 1 by H2 up to 1 by H10. Substituting the values of H1 and H10 here, we get 9C is equal to 1 by 3 minus 1 by 2, that is minus 1 by 6. So we get C is equal to minus 1 by 54. As we have to find out the value of A4 into H7, let us first find out what is A4. We know A4 is A1 plus 3D. So this is 2 plus 3 divided by 9. Therefore this is 7 by 3. And we know that 1 by H7 is equal to 1 by H1 plus 6 into C. Therefore 1 by H7 is equal to 1 by 2 minus 1 by 9. So 1 by H7 is equal to 7 by 18. So we have H7 is equal to 18 divided by 7. Therefore the value of A4 into H7 is 7 by 3 into 18 by 7, and this is equal to 6. So the value of A4 into H7 is 6, and hence the fourth option is correct. Next we consider the following question. In this question we are asked to find out three numbers A, B and C between 2 and 18 so that their sum is 25. The terms 2A and B are consecutive terms of an arithmetic progression, and the terms B, C and 18 are consecutive terms of a geometric progression. Let us write down the conditions again. So our first condition is 2 is strictly less than A, B and C, and all of them are strictly less than 18. Our second condition is A plus B plus C is equal to 25. Our third condition is 2A and B are consecutive terms of an arithmetic progression. So from here we can conclude that 2 plus B divided by 2 is equal to A. That means b is equal to 2 into a minus 1. Our last condition is b, c and 18 are consecutive terms of a geometric progression. So from here we can conclude that 18b is equal to c square. Substituting b is equal to 2 into a minus 1 here, we get c square is equal to 36 into a minus 1. So therefore c is equal to 6 into square root of a minus 1. We are considering the positive square root, as we know c is positive. As now we have the values of b and c in terms of a, we substitute them in condition 2 and we obtain a plus 2 into a minus 1 plus 6 into square root of a minus 1 is equal to 25. That is 3a plus 6 into square root of a minus 1 is equal to 27. We can write it as a minus 9 is equal to minus 2 into square root of a minus 1. Now taking square on both sides, we get a square minus 18a plus 81 is equal to 4a minus 4. So a square minus 22a plus 85 is equal to 0. We can easily note that this implies a minus 5 into a minus 17 is equal to 0. Therefore, a is equal to 5 or 17. Let us take our first case to be a is equal to 5. We know that b is equal to 2 into a minus 1 and c is equal to 6 into square root of a minus 1. Therefore, in case 1 we have b is equal to 8 and c is equal to 12. Now we can easily note that 5, 8 and 12 satisfy first and second conditions. Now we shall check the third and fourth conditions. So consider 2, 5 and 8. It is easy to note that they are in an arithmetic progression with the common difference three. So for these values, that is for a is equal to 5, b is equal to 8 and c is equal to 12, the third condition is satisfied. Now for the fourth condition, we consider 8, 12 and 18. We can note that they are also in a geometric progression with the common ratio 3/2. Therefore, a is equal to 5, b is equal to 8 and c is equal to 12 is such a choice for ABC we were looking for. Next we consider the case a is equal to 17. In this case we can note that b is equal to 32. Therefore, a is equal to 17. This case is not possible, as this choice of A, B and respectively if we find out C, they fail to satisfy our first condition. So the answer of our question number 5 is A is equal to 5, B is equal to 8 and C is equal to 12. Now we look at the following question. We are given the quadratic equation x square minus x plus p is equal to 0, and we are told that alpha and beta are the solutions of this quadratic equation. We are also given another quadratic equation x square minus 4x plus q is equal to 0, and gamma and delta are given to be the solutions of this quadratic equation. If alpha, beta and gamma, delta are in a geometric progression, then we shall find out the integer values of p and q respectively. First, note that alpha plus beta is equal to 1 and alpha into beta is equal to p, as alpha and beta are the solutions of x square minus x plus p is equal to 0. Similarly, we can write gamma plus delta is equal to 4 and gamma into delta is equal to q. Since alpha, beta, gamma and delta are in a geometric progression, we can write alpha is equal to A, beta is equal to AR, gamma is equal to AR square, delta is equal to AR cube for some A and R. Here we can write that P is equal to A square into R, as alpha is equal to A and beta is equal to AR, and Q is equal to A square into R to the power 5. So to find out the integer values of P and Q, it is enough to find out the value of A and the value of R. We know that alpha plus beta is equal to 1. So A into 1 plus R is equal to 1, and as gamma plus delta is equal to 4, we have AR square into 1 plus R is equal to 4. We substitute the value of A into 1 plus R in this equation and we obtain R square is equal to 4. That means R is equal to plus or minus 2. Now, therefore we get A, which is equal to 1 plus R. We could write 1 plus R in the denominator, as R is not equal to minus 1. So the value of A is equal to (1 by 3) when R is equal to 2, and minus 1 when R is equal to minus 2. We also have P is equal to A square into R and Q is equal to A square into R to the power 5. Therefore, clearly A is equal to 1 by 3 cannot be a possible choice for A, as we want P to be integer and Q to be integer. So the choice of R is equal to 2 is not possible for us. Therefore R is equal to -2 and A is equal to -1. So the value of P is -2 and the value of Q is -2 to the power 5, that means -32. So here the first option is correct. This is our 7th question. Let alpha and beta be the solutions of the quadratic equation ax square plus bx plus c is equal to 0. We denote b square minus 4ac by delta. If alpha plus beta, alpha square plus beta square and alpha cube plus beta cube are in a geometric progression, then we shall find out among the 4 options given here which are definitely true. So first note that since ax square plus bx plus c is equal to 0 is a quadratic equation, so a is definitely not equal to 0. And as alpha and beta are the solutions of this quadratic equation, we can write alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Also we have the information that alpha plus beta, alpha square plus beta square and alpha cube plus beta cube are in a geometric progression. Therefore we can write alpha plus beta into alpha cube plus beta cube is equal to alpha square plus beta square whole square. We know what is the value of alpha plus beta in terms of a, b and c. So let us find out the values of alpha cube plus beta cube and alpha square plus beta square in terms of a, b and c. We know that alpha cube plus beta cube is equal to alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So we substitute the value of alpha plus beta and alpha beta here. We get this is minus b cube by a cube plus 3bc by a square, which is equal to 3abc minus b cube divided by a cube. Next let us see alpha square plus beta square. We know that this is equal to alpha plus beta whole square minus 2 alpha beta. So therefore this is b square by a square minus 2c by a, that is b square minus 2ac divided by a square. Let us now substitute all these values in this equation. After substituting we get minus b by a into 3abc minus b cube divided by a cube is equal to b square minus 2ac whole square divided by a to the power 4. From both sides we cancel 1 by a to the power 4 and we obtain minus 3a b square c plus b to the power 4 is equal to b to the power 4 minus 4ab square c plus 4a square c square, which implies ab square c is equal to 4a square c square. So we have ac into b square minus 4ac is equal to 0. As we called b square minus 4ac as delta, we get ac delta is equal to 0. Now as a is non-zero, we can definitely say that c delta is equal to 0. Therefore, we can see that the third option is definitely true. But we cannot comment on the rest of the options as we have no information about B and C. We end this session here. We will resume our next session with problem number 8.